Hey everybody, Brian here. We're back continuing the series. And in case you're wondering, I have not filmed it all in one day. It's been done over multiple days. Today happens to be in the 90s. And yes, I'm still wearing the same long sleeve shirt. Why? Continuity. You know, if we ignore continuity in filmmaking, all kinds of weird, bad things can happen, like pickup trucks showing up in the background in films that are set in a medieval time period. So it's a pretty big deal, and I don't want to be a violator of the continuity principle in filmmaking. So anyway, we got Windows up and running in the last part of the series, and we're going to stay in Windows for now because all the prep work for Sonoma we're going to do there in Windows. We're going to gather some files, make some config settings, and then we're going to reboot and install Sonoma finally. So let's go. These next steps we're going to go through might seem like black magic. Well, welcome to the world of Hackintosh. There's a lot of really clever trickery involved in getting this all to work, so just be patient, and no matter how weird something will seem, it's all for a reason, namely to get Sonoma up and running with this particular setup of hardware. And I've actually put together a guide that shows all the steps I went through. That's on the Tony Mac x86 website. A lot of steps, but we'll go through them. So the first thing we're going to do is download OpenCore. I'm using version 1.0.0, so go to that OpenCore site and then download the release version. You can download debug as well. I'll be talking about the release. So download that and then extract it. I've already extracted it to my desktop. So then what you want to do is open up that distribution under x64. You'll notice this EFI folder. Just copy that and place it on your desktop. And then you'll notice in the boot folder, there's this boot x64 EFI. That's what you need there. Under OC, you'll notice this OpenCore.efi. ACPI folder will be empty. We'll fill that up when we build the SSDTs in a moment. The Kexts folder will also be empty. We'll fill that up when we gather all the Kexts that we need. And now open the drivers. You'll see a whole bunch of stuff, most of which we don't need. So I'm just going to select them all and then control-click the ones we need. What we need here is open runtime.efe, open HFS Plus, and reset NVRAM entry. So now I'm going to hit Shift-Delete. So that's what we need. You can add others later depending on what you want to do, but to get up and running, this is what we need. And then similar with tools, some stuff here we don't need. So again, I'm going to select them all, and I'm going to control-click what we actually need, which is Control MSR E2, Open Control, and Open Shell, and then Shift-Delete. So that's that. Go back into the OpenCore folder, under Docs, copy that sample.plist. Now open your EFI folder under OC and paste that in there. Rename sample.plist to config.plist. And then the next step is to create the Sonoma install USB. There's a utility in the OpenCore distribution that we can use for that. So click on your extracted OpenCore folder and go to Utilities. You'll see Mac Recovery. Select it, then right-click, and then choose Open in Terminal. And then there's a command that you want to run. And this command I grabbed from the Dortania guide for using Windows for the installer. See here, this is what we're doing. We're using a command that will download the latest version of Sonoma. So then paste that and hit Enter. You might get the same error. So if you get that error, just remove that 3 at the end and hit Enter. Okay, so now it's going to download about 770 megabytes worth of data. It's not like the full Sonoma install, which is usually about 14 gigabytes. When we actually install Sonoma through the internet connection, all the additional files will be downloaded. So for now, we just need this 770 megabyte installer. So I'll skip ahead to the end. So after your download has completed, go into your OpenCore folder, back to Utilities, to your Mac Recovery folder, and now you'll notice a folder called com.apple.recovery.boot. This is where that downloader placed those files that you downloaded. So you'll see this base system.dmg, which is about 770 megabytes, and then this base system.chunklist. So that's what you needed there. Now, with your USB drive installed, go to your Windows Disk utility, which in Windows 11 is called Create and Format Hard Disk Partitions. In my case, here's my USB drive. First, I'll delete the volume, and then I'll right-click and choose New Simple Volume. Next, next, next. Call it EFI. Next, and finish. And you can close out of that, and then open up your USB drive. Now what you want to do is take the EFI folder that you just created and copy that over, and then go to that OpenCore folder, Utilities, Mac Recovery, copy this folder, com.apple.recovery.boot, and also paste that onto the USB drive. And I'll skip ahead. And now we're going to gather some tools that we'll need for various steps of this whole process. The first tool we'll want is SSDT time. The link is in the description, so just click on that link, go to Code, download zip, and then extract it, and then mount EFI, Code, download zip, extract that as well, and then property, Code, download zip, extract that, gen SymBIOS. You know the routine by now. Code, download zip, and then extract it. USBToolBox. You probably thought I was going to tell you to go to Code, download zip, right? Actually now, you want to go to Releases. Download this windows.zip and extract that. Next, Hackintosh. This is something that we'll only use on the Mac, but we can download it here already. So Hackintosh.zip you want to download, and then extract that. Then IO Registry Explorer, another application that we'll just use on the Mac. Download this .dmg file. You don't need to extract that, just keep that as is. VDA Decoder Check, another application just for the Mac side. Go to Releases, download VDA Decoder Checker. Then Heliport, this is something that you might not end up using, but we may as well have it all in one place. Go to Releases. I don't recommend using an alpha version, but you could try that. So I'm going to download the latest release version, heliport.dmg. And then UEFI tool. Click where it says Show All Assets, otherwise you probably won't even see it. So UEFI tool, we want the Windows 64 version here. So download that and extract the zip file. Universal IFR extractor. We want the Windows version, so download that zip. And then modified grub shell. Just click on this .efi file, download that. And with this one, you want to go to your downloads folder, copy it. Now go back into your EFI folder under OC, Tools, and paste that in there. That's an additional tool that we'll need later. Then these last two we actually already have in our EFI OC Tools folder. Okay, so we downloaded all the tools we'll need, and what I've done is I created a folder on my desktop called Tools, and I just pasted everything we downloaded in there. Some are in folders that we extracted, some are just standalone files. So I suggest doing this so that on the Mac side you have everything in one place. Moving on, now we're going to create SSDTs. I won't get too deep into this. SSDTs, those are secondary system definition tables. You can read more on the link that I provided. In any case, these are just files that are used to modify how Macintosh will see the hardware on your motherboard so that it'll work correctly on the Mac side. What we want to do is use a tool that we already downloaded called SSDT time. Go to your tools folder where you have all these tools. And I have this SSDT time folder. So you want to run ssdttime.bat. Now the first thing you want to do is dump the current system ACPI tables. So that's option P. So just type P, enter, and it'll say something about the tables that it loaded. Go back to that SSDT time folder, and now under results, you'll notice it created this folder called ACPI. So with that done, there are certain SSDTs that we can call the essential ones, which are the ones that are needed for certain types of CPUs. In our case, one of them is the SSDT EC, which fixes the embedded controller so that the Mac can deal with it properly. So go back to your SSDT time window, and that's this option 2 here, fake EC. So just type 2, enter, and then you'll see some output. And then you can go back to your SSDT time folder, results, and you now have this SSDT-EC.aml and .dsl. The AML files are what we'll use later. DSL files are the text versions that end up getting compiled into AML files. SSDT time does that automatically, the compiling. And it creates this patches_oc.plist, which we'll use later. And then the next thing we want is SSDT USBX, which provides proper USB power on the Mac side. Let's go back to SSDT time. This one is number 4, USBX. So type 4, enter, and then B for default. And if you go back to your results folder, you'll now see that one as well, SSDT-USBX. Next, to enable proper CPU power management, we want SSDT plug alt. So back here in SSDT time, that one is number 5. So type 5, enter, enter again. And in the results folder, you now have this SSDT plug alt. Next, fix real-time clock. This is number 7, RTC AWAC. Type 7, enter. You should see that in your results folder. And now RHub, which resets the USB ports. This isn't always needed, but it's good to have just in case. In SSDT time, this is called USB reset. So just type 8, enter, return. In the results folder, now you have SSDT USB reset. Unfortunately, it's not all that easy. Now we're moving on to some black magic, some hack magic here. I'm using a 6950 XT GPU, and in order for that to work, we have to do a couple of additional steps. One of them is correcting unnamed bridges, which doesn't always apply. That'll depend on your motherboard, your GPU. But what you want to do is go into device properties. I'm going to go into device manager. And then display adapters. Here's the 6950 XT, and then go to details tab. And then you want to look for location paths. And then take note of what you're seeing here. Close out of here. Because I've already pasted here what I see there. So in my case, in Device Manager, I saw these entries, PCI 0000, PCI 0000. Those are known as unnamed bridges, unlike the ones before it, which are named bridges. One says PEG 1, the other says PEG P. So this SSDT will correct these unnamed bridges. So we can go back to SSDT time to build this bridge. It's number 9 PCI bridge. So type 9 and then enter, and then it wants us to enter a path in this format if we're on Windows. So I already have that here ready to copy and paste. So make sure you do the same and then enter, and then it did its thing. Hit enter again. And then go to your results folder, and now we need to open the .dsl file, which is just a text file, so you can open it in Notepad. So here are the 2 bridges it created. Notice this comment here saying to rename it if needed. From what I've gathered, people tend to do this renaming. We're going to rename from PXSX to GFX0. Apparently this makes it on the Mac size so that all will be well. And then save that. And because we edited this .dsl, we actually need to recompile back into the .aml. And we can do that with SSDT time actually. So go back to the SSDT time folder, click on results, right click, select open in terminal, and then just type /scripts/iasl.exe SSDT-bridge.dsl and hit enter. So what we just did was we recompiled this into a .aml file. And that's in our results folder. So all is good there. Moving on. I don't have Thunderbolt devices to test, but if you want to have the best chance of Thunderbolt working on this setup, there are some files that some very clever people have put together and made available on the Tony Mac x86 website. So I have a link there, and there you'll see this post number 4256. And there are these two files, SSDT THB4 RPO5 and SSDT DTGP. So download both of those and then put those into your SSDT time results folder. Even though we didn't use SSDT time to create these, it's just convenient to have all these SSDT files in one place. So I'll go to my downloads folder and copy these two, and then paste them into the SSDT time results folder. And there they are. So this SSDT-DTGP, it isn't Thunderbolt related. All it does is add a function call that simplifies some other SSDTs. So it's a good thing to have. And then DMAR. This is a pretty deep topic, so I won't get into it here. But again, there's a link if you want to learn more. The bottom line with this is if you want to have VTD enabled in BIOS and have the best possible stability with Wi-Fi, Ethernet, Thunderbolt, this is a recommended fix. So you want to remove the so-called reserved memory from the DMAR table, and on this version of the BIOS I know it has that reserved memory region, and we can use SSDT time to apply this fix. So go back to your SSDT time window and notice this version B, just fix DMAR. So just type B and then enter. Notice how it said located one reserved memory region. And now go back to your results folder, and now you have this DMAR file. Okay, there are a couple other SSDTs that sometimes people use, sometimes they don't. In this case, I think this one's a good one to use because it can fix IRQ conflicts that might cause unpredictable behavior, so probably a good thing to do. So back to our friend SSDT time. Notice here we have option 1, fix HPET. So just type 1, enter, and then the default, and then return. And in your results folder, you'll find SSDT-HPET. And now to help obtain proper diagnostics on the Mac side, there's also this SSDT SBus MCHC. This one, unfortunately, we can't build using SSDT, but there's a manual method that's explained on the Dortania guide. So I have a link there, and I'll run through how to do that. First, go to this URL on the Dortania site. Click manual. That's the only option to make this SSDT. Now click where it says edits to the sample SSDT. Now click SSDT SBus MCHC.dsl. It brings up a link where you can download this template, which we're going to edit in a second. Just click there where it says download raw file, and then copy that and paste into your SSDT time results folder. Now open this up as we're going to make a couple changes like we did with that SSDT bridge. It's just a text file. So I opened it in Notepad. First thing we want to do is make some changes. The Dortania guide is outdated, so we need to do a couple things that the guide doesn't tell us to do. Get rid of this whole scope section. So I've deleted that. We can delete this first external line here. And then we can uncomment out this device DVL0 block. So remove opening and closing comment. Okay, now go to Device Manager. Under System Devices, look for S-Bus, or rather SM-Bus. And then go to Details, BIOS Device Name. Notice here how it says PC00. In the template, it says PCI0. So what we do in Notepad is go to Edit, Replace, PCI0 with PC00, replace all. And you can confirm I made those changes. Now hit File, Save. And now you should still have that window open where you recompile this SSDT bridge. So we're going to do the same thing. In this case, the file we edited is called SSDT-SBUS-MCHC.DSL and hit enter. So that's been compiled. Go back to your results folder and now you'll see you have this SSDT-SBUS-MCHC.AML as well. Now that we've generated all these SSDTs, go to your tools folder, SSDT time, under results, and now just grab every single one of these .aml files. Patches OCP-list we'll use later, but we don't need to copy that now. So I'm copying these .aml files. Make sure you haven't missed anything. And then go to your EFI folder, under OC, ACPI, and I'm pasting those all in. So I have 11. Alright, now on to the most contentious topic in the entire Hackintosh community, which is USB mapping. I have a link that has a pretty good description of this process, and we'll go through it here. So remember we downloaded a tool called USBToolBox, so go to your tools folder. And by the way, when you extracted that file, it may have been called Windows. I renamed it USB Map Toolbox. And then you want to open the executable called windows.exe. And the first thing we can do is hit C. So you'll probably have this disabled, use native classes, so just hit N to toggle it. If enabled, Mac will use its own native abilities to manage USB instead of the USBToolBox Kexts. It'll still use the Kexts that we're going to build from the very last step of this, just won't use that particular file. So you can experiment and figure out what works best for you. I find that with it enabled, I get better stability with the USB ports, so less instances of ports being randomly ejected and that kind of nonsense. Also, bind companions disabled. Otherwise, if this is enabled, if you disable, say, the USB 2 personality of some physical port on your motherboard, it automatically disables the USB 3 personality as well. And you probably have a requirement for USB 2 and 3 devices, and by having this disabled, you have better control over what you enable and disable. So go to back. And the next step is to discover ports, so hit D. On my particular motherboard, there are two USB controllers, one that has 25 ports, and then there's the Thunderbolt controller that has 4. So with USB mapping on the Mac side, each controller can have up to 15. So on this one, I'm going to choose 15 out of 25, and then on this one, I'm just going to enable them all. So for this to work, what you need to do is take a USB 2 and 3 device and plug it into every single USB port on your motherboard. And after you've done that, you'll see in green and blue everything that got detected. And after you've done that, you'll see in green and blue everything that got detected. In my case, there are some that did not get detected no matter what I plugged USB devices into. So these two on the first controller, and these two as well. It also detects some internal USB controllers, for instance, a USB 2 hub for the Bluetooth or LED controller. So once you've done that, go back and now hit S. And at this point, what you want to do, just to help manage things, is add comments for all the ports that you know something about. So I've already done this, my comments in blue. So this is just a little note to myself so that I know what every single port is on this motherboard and how it's being detected on USBToolBox. And one thing worth noting, usually with a Type-C USB port, no matter how you plug a device in, it'll be automatically detected. Now, on my motherboard, this might be a defect, but when I plug the device into the top USB-C port, depending on how I plug it in, it was detected as a USB 3 device or a USB 2. This one here. So I had to edit this so that it's a Type-C without switch. The companion USB port is 12, so I did the same thing here. By default, these will be Type-C with switch, and so there are instructions on how to change that here. I doubt you will have to do that on this motherboard. I think mine is defective, but if you do detect that type of port, make sure you switch it to Type-C without switch, as opposed to the default just Type-C with switch. So in my case, I've looked at all the USB ports on the rear panel, as well as the USB headers that can connect to the case and the internal USB ports, and I determined what I need working. So I have various USB 2 devices like an audio interface, a MIDI keyboard, so I have to mix and match USB 3 and USB 2, so it amounts to a compromise. On this diagram, where I have an equal sign followed by something on the right hand side, that means I've included this in my map. Green is for USB 2, blue is for USB 3. So these two ports here, I've decided I'm just going to enable the USB 2 personalities, and then on these two here, I'm enabling just the USB 3. And then on the front case, I'm enabling just the USB 2 because I'm only going to plug in a mouse and keyboard there, so I know I don't care about USB 3. These correspond here to what's shown here. I don't care about this USB 2 hub. Obviously I want Bluetooth and I want the LED controller. Now again, your use case might be drastically different, so you're going to have to determine for your requirements what you need enabled and disabled. So going back, once you've determined what you want to enable, just type in the number. So in my case, I enabled 1, 2, 5, 6, 7, 8, 9, 11, 12, 14, 17, 18, 19, 20 on the first controller, as well as port 25. And then on the second controller, I enabled all. So you just literally type those numbers as shown here. 1, 2, 5, 6, 7, 8, 9, 11, 12, 14, 17, 18, 19, 20, 25. So those are the 15 from the first controller, and then I'm adding 26, 27, 28, and 29, which are the 4 on the second controller. So you do that, and then you type enter. So that cleared it out in my case, because it works as a toggle. If you enter a number, it turns it on or off, depending on how it was. So now if I just re-enter those, it'll be back to the way it was. And now that you've determined your USB port mapping, you want to hit K. And because I'm using native classes, I have to specify the SM BIOS, otherwise known here as the model identifier. So I'm using Mac Pro 1,1, and then enter. And then if you go back to your USBToolBox folder, you'll see a file called usbmap.kexts. Or if you did not use the use native classes option, this will be called utmap.kexts. I'm just going to rename it use native classes iMac Pro. And also you'll notice a folder called USBToolBox Kexts. Inside that there's a file called usbtoolbox.kexts. So I'm going to copy that. I'm going to go to the EFI folder, OC, Kexts, which is empty. Paste this USBToolBox Kexts, even though I won't be using it because I chose the use native classes option, but it's good to have it there. And then we want to go back up one level, grab the Kexts that was created when you typed K, add that to your Kexts folder as well. On the left side, what I've done is I've written in the port numbers that USBToolBox shows us here on the left. And the right side is what USBToolBox is specifying, and that's what we'll see on the Mac side. You can actually see this if you open up that Kext file that was generated. So under Kexts, USB map, use native classes, or yours might be called just USB map or UT map. Just click in there, In the contents, there's a text file called info.plist. You can just open that up directly. And here you'll see these HSO1, HSO2, etc. Those are for USB 2 type ports, and then the USB 3 type ports start with SS, SSO1, SSO3, etc. Anyway, I just wanted to show you that so you see where these numbers are coming from. One other thing worth mentioning is, even though we're mapping these Thunderbolt ports, they're going to be ignored because we're using that Thunderbolt SSDT. Remember, we downloaded that. And that file typically doesn't need to be touched, but in my case, because I had that weird oddity with one of the Type-C Thunderbolt ports seeming to be without a switch, I actually had to edit the SSDT. So if I go to the SSDT time folder, results, I downloaded the .aml, but to edit it, I need the .dsl. So in my case, I had to create that like so. And then in the results folder, I have the .dsl. And at the end is where the USB map occurs. And we have HSO1 and SSP1. On my motherboard, those correspond to the top Thunderbolt port. I needed to change this to 0A, which is hex for 10. 10 is that Type-C without a switch. And then I hit File, Save, and recompile that back to a .aml. So there I'm just typing the .dsl file name, the one I just edited, enter, and so that's been recompiled. So again, you probably won't have to do that, but just in case, now you know how to do it. And if you don't plan on using Thunderbolt, then this mapping will be applied, but with the Thunderbolt SSDT, this gets ignored. Now we're going to gather some additional Kexts that are needed. I should say this step is very hardware dependent. You don't want to be downloading EFI folders and applying it to your build because you don't know what hardware they were using. So this takes a very deliberate approach. The Dortania guide has some good information on choosing Kexts. In my case, because I knew I wanted to use the built-in Wi-Fi, Bluetooth, the 2 Ethernet controllers, Thunderbolt, that determined what I need. Regardless of hardware, there are certain Kexts that are always recommended, such as LILU. So you can go to the link, download the release version, virtual SMC, as well as a couple others that are related to it. These all have to do with system monitoring. Click on this link, download the release. Whatever green, that's a Kext used for providing all sorts of GPU-related functionality. Some people are actually not using this, they're using Newt RX, but because Newt RX is so new, and whatever green is more stable, for now that's what I'm using. Click on the link, download the release, and then SMC processor, SMC Super IO, those are actually contained inside this virtual SMC download. And then Radeon sensor, because we're using a AMD GPU, this will help get GPU diagnostics. So download the Radeon sensor. This SMC Radeon GPU is contained in this Kext that we just downloaded, Radeon sensor. Apple ALC, that's for audio. Download the release. That'll make sure the built-in audio on the motherboard works. NVMe fix can help third-party NVMe drives behave a little better on a Mac. So download that release. USBToolBox we already have, and we also have the Kexts that we created at the end of the USB mapping process. USB wake fix-up. This can help with certain USB wake situations where you have to hit a key twice in order for it to wake up. So this will fix it apparently so that you only have to hit once. But I'm not using it currently. Intel Bluetooth firmware. Download here. Intel BT patcher. That's included in the file that we just downloaded. Bluetooth fix-up. That's actually contained inside this BRCM patch RAM file. So download that. And then Airport IT LWM. This is to get the built-in Wi-Fi working on the Asus ProArt Z790, the Intel Wi-Fi. So download the Sonoma 14.4 Kext stable release. And then instead of using Airport ITLWM, some people prefer to use ITWLM. That's on the same web page as Airport ITLWM. So just go back there and you'll notice this file, ITLWM2 230 stable Kext. Download that. Restrict events. This is a Kext that can help with Apple updates working properly, as well as enabling us to rename the CPU. So download the release. CPU topology rebuild. It can help make sure Mac is utilizing the performance efficient cores and the threads on the Mac side. So I downloaded the release, and then Z790 XHCI unsupported. I found this seems to be needed when using USBToolBox and the native classes option, as I'm using. So there's a link to this on the Tony Mac x86 website. This post number 9 is from a user called Mr. Minimizer. So just download his EFI folder. And by the way, it's also in my EFI folder if you want to just grab it that way. So open that EFI folder that you just downloaded. Go to OC, Kexts, and you want to copy that Kexts and move it over to your EFI folder. Okay, so now go to your Downloads folder and open your EFI folder as well. Go to your Kexts folder. And now we want to just add these Kexts files that we downloaded. So lilu, I'll just open the zip file and I'm going to drag the .kext. Virtual SMC. Here there are several. Virtual SMC, SMC Super I/O, SMC Processor, and I've dragged those over to the Kexts folder, and the Radeon Sensor, which contains also SMC Radeon GPU. So drag those two over. And by the way, while you're at it, you can also copy this Radeon Gadget and put that into your Tools folder. That's if you want to have a little gadget showing GPU stats. An Apple ALC. You don't need the U version, just the one called Apple ALC. Drag that over. NVMe fix. Drag that over. Intel Bluetooth firmware. And recall we also need this Intel BT patcher. So I'm dragging those two. Bluetooth fix-up is contained in this BRCM patch RAM Kext. So I'm copying that over. Airport IT LWM. Drag that over. IT LWM. Drag that over as well. Restrict events. And CPU topology rebuild. So there, now you have all the Kexts that you need. Continuing along with all this hack magic, now we're going to edit the config.plist. Earlier you took the sample.plist, copied it to your EFI OC folder, renamed it to config.plist. So now we're going to go back to the tools folder we created where we added a whole bunch of useful tools. And you want to go into property and then open this property.bat and go to File, Open, and then go to your desktop, well, wherever you saved your EFI folder, and then to the OC folder, config.plist, open that up. The first thing we can do is just delete these warnings up here, and they're not needed for anything. And now go to File, OC Clean Snapshot. It should already see the correct folder. You want to make sure that your OC folder, EFI OC, select folder. And now what it's done is it looked at your ACPI folder and added these entries that correspond to all those SSDTs that we collected and created. It also looked at your Kexts folder, added those later on, as well as drivers, tools. Okay, now moving on to the delete and patch section here under ACPI. So SSDT Time created a file for us called patches_oc.plist. And that contains a couple entries that we need. It created some entries when we added this DMAR file, as well as when we created an SSDT HPET. The other files it created didn't really add anything we need in this patches OCP list. So we need to open up that file because we're going to copy some of those entries into our config.plist. So go to File, back in Property, Open. So we're going to have a second file open now. And just go to wherever your tools folder is. and where you have SSDT time, under results, and just open the file called patches_oc.plist, and you want to select delete, and copy, and then go here, just delete this entry because it doesn't have anything we need. It's just from the template and they're already set to false. So just hit delete, and now click on ACPI, right click, paste. And now what it did was added this delete entry that corresponds to dropping the so-called DMAR table. So that's what we want. Let's reorder these so that the add section is for delete. And now for patch, similar process. Go back to your patches_oc list that you already opened in proprietary. Click on patch, edit, copy. Go back to your config.plist in proprietary. And what's there by default isn't anything we need. Just delete the section. So I selected it, hit delete, and then click on ACPI like we did when we added that delete entry. Right click, paste. Now it added 5 patches. I'm just going to reorder this a little bit, move the patch entry under delete. Now there's actually an additional patch that we need, and this is a patch that users of AC Z790 boards as well as some other fairly new boards are using. And in all the examples I've seen of people using an Asus Z790 ProArt board, they seem to be using these 2 patches, which I show here. So what I'm going to do is just copy these 2 patches, Control C, and then back in the config list in proprietary, I'm going to hit right mouse key and paste. Now you'll see that it added these 2 additional entries, so now we have a total of 7 patches. And I'll provide this text in the description so you can also just copy and paste. And moving on, in this config.plist, in the corks, you can just keep everything as they were already by default. No changes here. The next section that we need to worry about is booter corks. We can delete some of these additional entries that were there by default because they're not needed. So under this MMIO whitelist, I'm just going to delete these 2 entries, as well as patch. This is there by default and it's nothing we need. So I'm going to delete that. Now let's just focus on this corks section, booter cork. So there are a few things here we need to change from the default. First thing, devirtualize MMIO. Initially that's set to false, so set that to true. And then this enable write unprotector, initially that is set to true, so change that to false. And what I'm doing here is just according to the Dortania desktop comment late guide. And then a couple other things to change here. We want rebuild Apple memory map to be true. Resize Apple GPU bars. Because I enabled that in the BIOS, you may recall, we enabled so that resize bars would work. That means here we set that to 0. I know, it's very logical, right? Then in the desktop comment late guide, it says to set virtual map no. Declares that otherwise Asus board will not boot. But every example I've seen of people using this motherboard, they have it set to true. So keep that as true. I think that's the default as it is. And then sync runtime permissions. I want that to be true. Remember when we talked about the 6950 XT GPU? Turns out we have to spoof Mac into thinking that it's actually a 6900 XT. And the way we do that is through this so-called device properties entry. I'm just going to copy and paste what I have here. And I'll also provide this so you can readily do the same thing. And we can delete what's already there. What's already there is for the audio layout ID, but we don't have to do that via device properties. We can just do that later through a so-called boot argument. So I'm just going to delete what's already there. And then under device properties, add, right click, paste. And now you should see this entry. And all this does is specify this device ID to be 73BF, which we entered this way. And then a couple other parameters that I think are mainly cosmetic. The main thing is the device ID. By the way, some people are doing the same thing, but without adding a device properties add entry. They're doing it via an SSDT, and you can do that as well. There are some threads that I provide that have some info on that, but I find this approach far easier, and the SSDT approach, from what I gather, it doesn't have any advantage. The next section is kernel add. Remember when we did that file OC clean snapshot earlier? So that looked at various folders and added certain things to this config file that we need. In the case of the Kexts folder, it added all these entries that you see under add. So I have 18 of these entries. But the thing about Kexts is that in this config file, they actually need to be in a certain order. So this one called Lilu, that one should always be the first one. And what you can do is just simply drag them. So I'm putting this into the first position. And then usually the next one is virtual SMC and then whatever green. Again, I'm going to find those in here and just reorder them. Virtual SMCs down here. I can drag that up. And likewise with the others. So you can actually follow the ordering that I show here. Again, it's these first couple that are the most important. The other ones aren't so important, though that said, I have read people saying that this ordering is important. So these Kexts related to Bluetooth and Wi-Fi. Again, I haven't confirmed that, but this is the ordering that I'm using. So I'll skip ahead, and then in the end, you'll just want to make sure that your Kexts are ordered in the way that I'm showing here. Once you've done that, your kernel add section should look like this. And a couple notes, you might not need this particular Kext Z790 XHCI unsupported. I've noticed that this seems to be needed when I choose the Use Native Classes option. Otherwise, if I don't use that and I boot into Sonoma, my mouse won't work, for instance. So using this seems to ensure that all is well on the USB side. Earlier, I renamed my USB map. I renamed it to USB Map Native Classes iMac Pro. And also because I'm using the Use Native Classes option, I've set USBToolBox Kexts to false, so it's not being used, but this one is being used. If you don't use the Use Native Classes option, USBToolBox will generate a Kext called UTBmap. So just make sure if you're not using the Use Native Classes option that you enable USBToolBox Kexts by setting this to true. Also some words about these two Kexts. ITLWM will not get you Wi-Fi during the Sonoma install because it requires that heliport application that will only work after install. If you use Airport ITLWM, you'll have Wi-Fi right off the bat during the Sonoma install. Some people prefer to switch later to ITLWM because they get more reliable iServices like iMessage and FaceTime. So when you config, just make sure you have one enabled, not two at the same time. So I've set Airport ITLWM Kexts to true. ITLWM Kexts I've set to false. And that's all I wanted to point out here. Before we get to kernel emulate, there are a couple entries that we can just delete. They're not needed. So you'll see this block entry. Notice how the two entries that are already there have the enabled set to false. You can just delete those. And then there's this force entry that also has an entry that's disabled. So we don't need that. And then the patch section has 10 entries that are all set to false, by the way. And none of them are actually needed for our situation. So you can just delete all those. So now we can go to this emulate section. And this is done to make Mac think that our 14th gen Intel or 13th gen or 12th or 11th is a Comet Lake, 10th generation Comet Lake. Now on the Mac side, it'll still use the threads, the cores of the 14th generation CPU. This is just a little bit of trickery needed for Mac to not complain about the CPU. I'm just copying what I have here. And then over here in the config file, I'm just going to delete this emulate entry. And then back to where it says kernel, I'm going to right click and paste. And then it's added this emulate section. And you can reorder if you want, it's not that important. So I'm just moving emulate to where it was. Now we deleted these patch entries. One thing worth mentioning though, the Dortania guide talks about using a patch for Intel i225V Ethernet controllers, but Sonoma already has native support for those types of controllers. On this motherboard, Z790 ProArt with the Intel i226V controller, it doesn't need any kernel patch, it doesn't need Kexts or anything, it just works out of the box. Next, we're going to move on to the kernel core section. Now, you really want to make sure you get this right. A lot of bad things can happen if this isn't set up correctly. First thing, we'll look at Apple XCPM CFG lock. If you don't plan on unlocking CFG on your BIOS, then you can set this to true, but the OpenCore developers suggest set this to false and actually unlock your CFG if you can. Now in our case, we can unlock it, so we're going to set it to false. And then the next thing, custom SMBIOS GUID. Now when I first tried installing Sonoma, I had this set to true, but then I got an error telling me I needed to update my firmware in order to install to my selected volume. Reading up on what can cause that error, it suggested to set that to false, which will also force us to set a platform parameter later on. Disable IO mapper. This is something recommended to set to false if you're using VTD enabled in BIOS. If you have a DMAR table that you've edited and you're dropping the existing one, which we did, as well as if you want to use a Quantia Ethernet, and in general it seems to be recommended. So we're setting this to false based on those criteria. Disable IO mapper mapping. We're going to set this one to true because apparently that can help things like Wi-Fi, Ethernet, Thunderbolt devices working properly when VTD is enabled. It says certain criteria, but in our case they're all met. Next, we're going to set disable RTC checksum true, because previously when I had it set to false, I noticed these types of errors when I rebooted. Extend BT feature flags, you can set this to true. This is also something that can help ensure stability and hardware functionality. In this case, apparently Bluetooth can benefit from it. Force a Quantia Ethernet if you want to use the 10 gigabit Quantia Ethernet on this motherboard. Set that to true. Panic, no Kext dump. Set that to true, as well as the next one, power timeout kernel panic. These two just help ensure access to certain types of logging and to prevent kernel panics that might otherwise occur. Provide current CPU info, we'll set that to true as well. Not a lot of info out there on this one, but it ensures on the Mac side there's some sort of appropriate use of those efficient cores. And then third-party drives we can set to false, as well as XHCI port limit. This is a weirdly named quirk. When set to true, you're telling Mac to not apply a 15-port limit to a USB controller. But reputable experts on Hackintoshes and USB mapping suggest to set that to false. Have Hackintosh apply a 15-port limit, otherwise you can have weird stability issues. And that's it for quirks. Okay, so let's move on to miscellaneous boot. Notice hide auxiliary. If that's set to true, then when OpenCore loads, you want to hit the spacebar in order to see all the available drives and options. That supposedly just makes the boot process a little faster, so I kept that as the default. Takeoff delay I set to 5,000. Timeout I set to 10. And this just gives me more time to think during the OpenCore boot process. Otherwise, it'll just automatically boot to the currently selected drive. And that can be pretty annoying, so these settings just give you a little bit of extra time to think, which is a good thing. And now under debug, you want to change these to true. And have the other settings according to what I show here. So target 67, pretty cryptic setting. What these do are just make it so that we will get some additional debug information, which can be helpful if you're seeing problems during install, as well as a change to this display level. And then let's go to security, vault, just type in optional, make sure you spell it correctly, allow set default, change to true. Scan policy you can set to 0. And now the most important part, at least for me, secure boot model. I have to set this to disable, rather disabled. Now if you read online, you'll see various accounts of people saying that when you install Sonoma, you can set that to disabled and then later just set it back to default. But I was never able to successfully get Sonoma to boot with that set to default. So I've kept it to disabled, and from what I understand, it doesn't really have any negative impact on anything. The tools section was automatically set up when we did that file OC clean snapshot earlier, so nothing to do there. Now we're on to the NVRAM section, non-volatile RAM. NVRAM is a small amount of system RAM that Mac will use to retrieve certain system parameters. And in certain cases, we have to add additional parameters. So I'll go through some of the entries that I added. The first is rev patch, which has to do with the restrict events Kexts that we're using. So if you go to that website for restrict events, you'll find this rev patch entry. So in our case, we add CPU name so we can name the CPU in a way that'll show up under the Mac about system information. And this SBVMM, which can allow OTA updates for unsupported models. And then rev CPU name, see how I've named this to correspond to my 14th generation i7 14700K. That's also part of this restrict events Kext, so I've just applied it as so. And then rev CPU, again, under restrict events. As I understand, these two are used hand in hand, so just set to 1, you'll be all set. And then other entries are default. Then boot arguments is an important one. Most of the ones I'm using there are pretty default, but I'll talk about some of the more interesting ones. So ALC-ID. That corresponds to Apple ALC Kexts that we're using to enable the motherboard's audio. So the way to determine that ID is you can actually go to the Apple ALC website and then under resources, just find your audio codec. In my case, it's this ALCS1220A. And then I happen to know that this layout 13 works because the user Casey on the Tony Mac website, he talked about that. How he got it working for his Asus ProArt Z690, and the audio codec and the layout is the same as the ProArt Z790. So I tested it, I know that works. In your case, just make sure you look at your codec and try the various entries, look at the release notes, and hopefully for your motherboard and codec, it's already a layout ID that works. This one here and the next one are related to the whatever green Kext. So this one just does a rename of a parameter, which apparently is needed for AMD GPUs. And then also, because a 14th generation CPU iGPU will not work on a Mac, you need to disable it. And that's done with this boot argument. And then an entry related to the CPU topology rebuild Kext. This one here apparently can make the Mac use the E-cores of an Intel chip in some sort of sensible way. And then everything else was default, so those are the changes I made. I'm going to now copy and paste the text that corresponds to these entries that I have in this guide. The link is in the description. So I'm just going to copy that. And then in Proprietary, I'm going to delete the existing add and delete entries under NVRAM, because that's what we're going to paste in right now. So I deleted those, now I'm clicking on NVRAM, right click, paste. So that added exactly what we had over here. This legacy schema, we don't need that, so you can just delete what's already there. And that was NVRAM. Time now to enter platform info. Yeah, the fun keeps building up. First save and close your config file. We downloaded Gen SymBIOS earlier, so go to your tools folder, Gen SymBIOS, and then run gen SymBIOS.bat. And if you don't see Mac Serial followed by some version number, then just type 1 enter to install Mac Serial. Now hit 2, and then go find your Config.plist. It's in your EFI, OC folder, so Config.plist, and just drag into the Gen SymBIOS window, hit enter. Number 7, note how for me it says currently enabled. If that says currently disabled, then just type 7 enter. It just toggles it, so make sure it's currently enabled and confirm that your plist has been added here. And now what we can do is type 3, enter. I'm using an iMac Pro SMBIOS, and then enter. And then it says flushing SymBIOS entry 2, and then it lists your config file that you added. So now you can close out of there, reopen your Config.plist, and now you will see under platform info this generic section has been edited based on what Gen SMBIOS did. And then the one other thing we need to change here is for processor type, change that to 3841. That's kind of a cryptic entry, but apparently that corresponds to a CPU type that most closely resembles the 14th gen Intel. So generic is all set now. And then the other platform info parameter that you might have to change is update SymBIOS mode. Remember earlier I talked about how update SymBIOS mode and custom SymBIOS GUID work hand in hand. So in my case, because I'm setting custom SMBIOS GUID to false, that means I have to set update SymBIOS mode to create. If you set custom SymBIOS GUID to true, then update SymBIOS mode should be custom. In my case, I'm using create along with custom SymBIOS GUID false. And now moving on to this UEFI section, APFS. There's one thing to note. You can add -1 and -1 to these min date, min version. And apparently that'll allow you to use APFS with versions of Mac that you otherwise wouldn't be able to use it with. Other than that, everything is set to default. And then Apple input, audio, you don't have to touch that. Drivers was added automatically when we did that clean OC snapshot. So it added these 3 entries. Input, output, we don't have to touch. Now we'll look at protocol overrides under UEFI. By default, everything I think is false except firmware volume. So I set this to false because that's needed for when you're using File Vault, which I'm not using. Apple RTC RAM I also have false because remember when I mentioned this disable RTC checksum, which I set to true to avoid this system as posted in safe mode error. So if you look at the Dortania post-install troubleshooting section, or rather the section on fixing RTC, it basically says here that if this disable RTC checksum didn't fix the issue, then using Apple RTC RAM is the next step, which involves a lot more that I'm not going to get into. But in my case, it's not needed, so it's false. And then under Quarks, I didn't change anything. This is just all default. Reserved memory, there's some disabled entries here, so we can just delete those. Hit File, Save. So now your config.plist file is in order. And now we're going to unlock CFG on the BIOS. So you can actually skip this step if you want to just set that kernel core Apple XCM CFG lock to true. In any case, I'm going to show you how to actually unlock it, which is the preferred way according to the experts. Here's what you do. First, you need to make sure you have your BIOS file handy. If you don't, just go to the website under BIOS and firmware, which you'll find under this driver and utility tab, and just find whatever BIOS you're using. I'm using 2202. I've put it on my desktop here. There it is, this .cap file. And then earlier we downloaded a tool called UEFI tool. So go to your tools folder where you downloaded all those tools earlier and launch UEFI-tool.exe. And now go to File, Open Image File, and then find where you downloaded your BIOS image. So here's mine. I'll open it. Now go to Action, Search, and make sure you select the Text tab, and make sure Unicode is selected here on the right. And just type CFG lock, which is what we're going to search for. Hit OK. So we found something in the search results, and that indicates that this BIOS can be CFG unlocked. Just double click on one of these entries. I'm going to double click this first one, and it takes us to this setup section under the overall hierarchy here. And with that selected, just right click and then choose Extract As Is. And then go to your tools folder where you have this UEFI tool. For me, it's under Desktop Tools. And just name it setup.bin. Save. Now you can close. And with that step done, now we're going to use this ifrextractor.exe program. And actually what we want to do is just click on the Tools folder where that program is located, right click, and choose Open in Terminal. Now what you want to do is run this command. Now if you go back to your Tools folder, you'll see an additional text file. Now open that. It's just a text file. And go to Edit, Find, if you're using Notepad as I am, and just type CFG lock and hit the down arrow. And notice it found CFG lock in this section. And the key thing to look out for here is this var offset, which in my case is 0x44, and var store ID 0x1. Take a note of these values here. And now what you want to do is just select this value, copy it, and go to the very top again of this file. And in the search box, type in or paste in this var store ID : space 0x1, and then hit the down arrow. And notice how we have a search result. And the key thing is this CPU setup. So that tells us we're good to go. Now write down that value that we found earlier, that 0x44 for the var offset, because we're going to need that to do a manipulation here in the next step to unlock CFG. Okay, we're ready to reboot and install Sonoma finally. So this is a good time to just do a sanity check on your EFI folder. Make sure everything's in place. If you've been following along, then everything should be in place. And if you were editing a version that was on your desktop, just make sure you copy it over to your USB drive. Earlier, I had you copy that over when we had just a basic EFI folder, and I suppose that was premature. You can write in the comment section about how awful of a human I am for having you copy that prematurely. But in any case, just copy it over now if you need to, so that on your USB stick you have everything you need. com.apple.recovery.boot folder, your EFI folder with all your SSDTs, Kexts, tools, drivers, of course your Config.plist, and also I copied over the tools that we downloaded earlier, just so that we have them on the USB drive, and on the Mac side we can copy those over. We don't have to re-download them. Okay, with that sanity check out of the way, you're ready to install Sonoma, and we'll go through that in the next video, as in this video we already covered a ton of ground. We're already past an hour, so I hope now you have a pretty good understanding of how to set up a Hackintosh, and regardless of the kind of Hackintosh you build, all these steps that it took you through, they'll allow you to build pretty much any imaginable Hackintosh in the future. Well, as long as Hackintosh still has a future. So stay tuned for the next video.